Okay, I will be reviewing and teaching net ionic equations. Net ionic equations is basically just simplified chemical reactions. They only really take into account things that actually change. And it's really based on insolubility charge, which I'll kind of summarize in a second, but it ignores the things that really don't change. I do have a example equation right here. I have Na2CO3, which is aqueous, plus CaCl2, which is also aqueous, and that equals 2NaCl, aqueous solution, plus CaCO3, solid. That solid is very important. We know that CaCO3, or calcium CO3, is solid because of the insolubility charts. And because we know it's solid, we now know that this cation, the calcium, and the carbonate anion is the only thing that actually changes, because it goes from calcium, which is aqueous, and the carbonate, which is also aqueous, and it changes into solid. So the net ionic equation is only going to review these. It's going to ignore the Na and the, if I can find it, the Cl2. These are actually called spectator ions because they spectate. They don't do anything. They don't change. They just spectate the actual equation. That's why in this net ionic equation, they're not there. See, now in this equation, we have the Ca, which is a cation, which I have the positive there, plus the carbonate, which is an anion, which I have the negative, equals the CaCO3. And that is solid. Actually, I should probably label these as aqueous as well, because they change from aqueous to solid. So this is the net ionic equation. Remember, we aren't including the Na or the Cl2 because these both turn into the NaCl2, which is just aqueous. So it doesn't really change the state. And obviously this is all based on the insolubility charts. So